All right, pulley problem 3 is going to start out with a kinematic. So first question that they ask in this problem is determine the acceleration of the system. The system just means these two guys considered together. M1 and M2 together make up the system, and they have the same acceleration. Now, to find the acceleration, you cannot use the summing of forces here, because what's missing? M1. If you knew what M1 was, then you could use summing of forces. But we don't know what this mass is, so we can't use that approach. But if you read the problem, we're told that M1 starts 2.2 meters above the ground from rest. V initial is 0 meter per second. What else do we have? The time for it to reach the ground is 4.2 seconds. That information is enough to calculate acceleration. So we're going to find the acceleration with a kinematic. X equals 1/2 at squared. Or if you prefer, you could say y, because we're actually dealing with the vertical here. So y equals 1/2 at squared plus v initial t. V initial is 0, so that goes away. So taking this right here, a equals 2y over t squared. So that's going to be 2 times 2.2 meters over 4.2 seconds squared. So this gives an acceleration of 0.249 meter per second squared. Okay? So you get the first question with a kinematic. All right. Second question, determine the mass of M1. Now to do this, we have to sum the forces. So I'm going to make some room here to solve it. So you have the question in front of you now. So I'm just going to delete all this text. All right, so we're trying to find out what M1 is. So the way we're going to do it, we're going to go free body diagram, sum the forces, solve for M1. All right, now, I just want to mention something. Notice that M2 is touching the ground. So I've seen a lot of kids over the years include normal force for a problem like this. You do not want to include normal force, because what happens a split second into the problem? M2 comes off the ground. So there's no normal force in this problem. Once the problem begins, the normal force is gone. Okay, so I'm going to erase the ground, and we'll just use this diagram here to do our free body diagram. Now, before we set up the free body diagram, let's do sign conventions. Which way is M1 going to move? Down. So down is plus, up is minus for M1, right? Make the direction of motion positive. Which way is M2 going to move? Up. So notice that the sign convention goes around the pulley, right? So it goes like this, positive, positive, positive. The sign convention wraps the pulley. Okay? Very important. Now let's label the forces. Okay, so looking at M1, the forces acting on M1 are, we got M1G down and tension up. Now, which way is M1 going to be accelerating? Does M1 accelerate up or down? Down. M1 accelerates down. So what does that tell us about M1G and T? Which force is bigger, M1G or T? M1G is a little bit bigger than T, and that's why the acceleration is downward. Now, what if these two forces, just hypothetically, what if these two forces were equal to each other? What if tension and M1G were perfectly equal? Then M1 would either be at rest or moving with a constant velocity. Because remember, moving with a constant velocity is also zero acceleration. Okay, so let's go to M2. Forces on M2, we got M2G down and tension up. Okay, so free body diagram's done. Now we sum the forces. So we're going to go M1, M2. So summing the forces for M1, realize that down is positive. We're going to get M1G minus T. What is that right there? That's the sum of the forces. The sum of the forces always equals MA. All right, so we just wrote an equation. Okay, now let's go to M2. We sum the forces for M2, realizing that up is positive over here. So we're going to get T minus M2G equals M2A. And we now have two equations and two unknowns. The two unknowns are T and M1. Okay? If you have two equations and two unknowns, you can solve it. So let's add the two equations together. Let's add these two equations like that. So the T's cancel out, right? Plus positive T and negative T. And then so what we get is M1G minus M2G equals M1A plus M2A. And we're trying to get M1, so I'll rewrite this again. M1G minus M1A equals M2A plus M2G. So we can factor out M1. So M1G minus A equals M2A plus G. And then lastly, we get M1. M1 equals M2 A plus G over G minus A. Move that out of the way. Now look, why am I showing this to you? Look at the College Board. When you take the AP exam in May, they're going to have you do free response in terms of variables. So for example, take this exact same question. What the College Board would have said is solve for M1 in terms of A, G, and M2. Okay, and then this would be the answer. In terms of variables, this would be the answer, right? Or anything that's algebraically equivalent. All right, so what you do is you plug the numbers in, you plug numbers into that, and you get M1 equal to 3.58 kilograms, right? Guys, gravity, see the G right there? See this G right here. Are you going to plug in 9.8 or negative 9.8? 9.8, because realize up here, didn't you already pay attention to the sign conventions? When we summed the forces, did we pay attention to plus and minus? Yeah. So once you've summed the forces, you plug all the values in, absolute value. Nothing gets plugged in as a negative. Okay? So we have M1, and then what else does the problem want? Tension. So how do you find tension? You can either plug into this equation for tension, or you can plug into this equation for tension. Both equations will give you the same thing. So for example, this equation, you're going to go T equals M1G minus M1A. So that's going to be T equals M1G minus A. Plug in the values, and you're going to get 34.2 newtons. Okay?